So in this lesson, we are going to convert binomial distribution into normal distribution. Okay, so one side we can write down here binomial distribution. Okay, on this side we can write down here normal distribution. Binomial distribution, x is distributed binomially and it is n and p. N is number of fixed trials, so we can write down here number of fixed trials. Okay, and p is probability of success, right? Okay, normal distribution, because we have used x here, we can use y. So y is distributed normally and it is mu and sigma square. And we are converting from binomial to normal. So basically, binomial is for discrete data. Okay, discrete data means fixed data, and normal is for continuous data. Continuous data. And this is discrete and fixed data. Okay, now remember here expected value mu, we need to convert it in terms of n and p. So mu is n times p, and mu is also known as expected value of x. So mu equal to np. Okay, sigma square we can write down. Sigma square is np and it is 1 minus p. Is that okay? Np 1 minus p. So if you want to find sigma, then sigma will be square root np and 1 minus p. Okay, so this is what. And here to convert binomial into normal, we will use continuity correction. So I'm writing short form continuity correction. Okay, what is this continuity correction? That I'm going to explain you now. If n is very large, if n is large and p is close to 0.5, p is probability of success close to 0.5, then binomial distribution, you can convert it into normal distribution by using continuity correction. Is that okay? Now, if question comes like this, here x is distributed binomially and here is 10, number of fixed trials, and probability of success is 0.2. You need to convert it into normal distribution. Okay, so here number of fixed trials are n, this is n and this is p, right? So y distributed normally, and here we can write down np and it is np 1 minus p. Okay, bracket close. So what is n here? What is n here? Guys, what is n here? 10. So it should be n is 10 and p is how much? 0.2. So 10 times 0.2 is 2. So we got 2 here. Similarly, if you see here, np we have just found 2. So write down np is 2. What is 1 minus p? So it should be 1 minus 0.2. 1 minus 0.2 means 0.8. 2 times 0.8 is 1.6. So we got 2 and 1.6. So here we can write down y is distributed normally and we can write down here 2 and 1.6. Is that okay? Now let's take another example here. Guys, any question? So everything we are converting in terms of n and p, yeah? And after 5 minutes, I'm going to use continuity correction. We will have a look. So this is for you. If x is distributed binomially, number of fixed trials are 30 and probability of success is 0.5. Convert it into normal distribution y. Can you do it for me now? So please do it and let me know what is your answer. Yeah. You are using NP. So 30 times 0.5 is 15. So this is 15. Now NP is 15. And what is 1 minus P? 1 minus P is 1 minus 0.5, that is 0.5. Yeah. So 15 times 0.5 is 7. Okay, it should be 75 and then 7.5. So here you can write down y is distributed normally. It is 15 and 7.5. Okay, so this is for you. Just try. And you need to tell what is NP. Okay, what is NP value, Kavish? 0.6. Okay. Faizan, what is NP 1 minus P value? Okay, can you go in decimal? 0.42. Everybody's okay with that? Yeah, everybody's okay with that? Now, next one is continuity correction. Okay, so I'm going to explain you what does it mean. Continuity correction. Continuity correction. Okay, so here continuity correction. So see, there is one problem here. If outcome of binomial distribution is discrete, whereas outcome of normal distribution is continuous, right? Whenever we solve binomial distribution question, so we know outcome of binomial distribution is discrete. Okay, we can write down here binomial distribution, and other side normal distribution. Okay, so in binomial distribution, outcome is discrete. Okay, let's write down outcome is discrete. Okay, in normal distribution, outcome is continuous. Okay, so we will apply continuity correction to approximate a discrete distribution here. So what is discrete distribution? So see here. So here, suppose number of fixed tiles are here 1, 2, 3, 4, and 5. And I have taken example of 2. So there is a bar here on 2. Is that okay? And there is a 1 here, right? So if you see here, this is bar on 2, right? So if we draw it separately here, so this is number 2, and just let's make it big bar here, this bar 2. And 2 is covering two values. One is here 1.5 because 1 is here 1.5 and it is covering 2.5, right? It is just like a lower bound and upper bound. So from where 2 is starting? So 2 is starting from there, this black line, right? This side is 2. Okay. And after 2.5, once you go on 2.6, then 3 will start. So continuity correction for 2 is between 1.5 and 2.5, right? Okay. Why we are not taking just 2? Because if you are taking just 2, there will be a line, and area of one line in normal distribution is equivalent to 0. Okay, so that's why we require here continuity correction. This is your lower bound value of 2 and this is your upper bound value of 2. So how long 2 is? Between 1.5 to 2.5. So this you can write down here for 2, probability x equal to 2, we can write down 2 is between 2.5 and 1.5. Is that okay? And we can write down P. Everybody happy with that? So 2 is not just 2, it is between 1.5 and 2.5. You can ask, sir, why not we are taking 1.4? If you're taking 1.4, that will be part of 1. From 1.5, 2 starts and it goes until 2.5. Everybody's okay? Any question? Okay. Okay. Here is example. If P x is equal to 3 and we are applying continuity correction. I'm writing in short continuity correction, and this is from binomial to normal we are going. So we are applying continuity correction. So again 3 bar will be from 2.5, right, to 3.5. We are taking this bar. Is that okay? So after applying continuity correction, you can write down 2.5, okay, and this x, which is equal to 3, x is between 2.5 and 3.5. Is that okay? Now another one is very important. So if we are saying p x is greater than 4, right? So once we apply continuity correction, again continuity correction, so 4. So 4 bar, let's make this blue bar here. So this is 4.5, okay, and this is 3.5. So this is 4 bar. Can you see my blue color, right? Okay. So here which sign it is? Greater than 4. 4 onward. So 4 is finishing, see my black ink here, 4 is finishing here, and greater than 4, it should be greater than 4.5 here. So p x greater than 4.5, because they are saying here greater than, and 4 last value is this yellow part, that is 4.5, and here it is showing greater than 4. So this yellow and yellow is matching. Yeah, so it should be greater than 4.5. Is that okay? So where 4 is finishing? From that point onward, that is 4.5. So 4.5 onward. Is that okay? Now if we take another one like p x greater than and equal to 5. Now in the previous example there was no equal. Here there is no equal sign, and here it is equal sign. So what changes will be there when we are applying continuity correction? So in this case, what will be your answer when you are applying continuity correction? Greater than and equal to 5. Anybody else? Greater than or equal to 5. Yes. Which value will take here? 4.5. Because if you take equal sign, it hardly matters. It is not affecting the result. So greater than and equal to, they are both giving same value. Okay. So x greater than 5 is exactly like x greater than 5, and greater than 5 is how much it should be? 4.5. X greater than 4.5. Is that okay? Is that okay, guys? Rohan? Clear? Okay. So here x is greater than 4.5 because our 5 bar is starting from 4.5. Okay. So we are taking this line because it is greater than or equal to. So we are moving in this direction, including 4.5. Okay. So that's what it is resembling here. Okay. Next question is probability when x less than 6. Here it is George, less than sign. Less than 6. So when we are applying continuity correction, okay, continuity correction. So 6 value. So if we draw a bar here, and this is our 6 value. 6 value is between 5.5 and 6.5. This is our bar. Okay. This is showing less than 6. So our 6 is starting here. Can you see this black line? Can you see this? Our 6 is starting 5.5, but we are taking lower value, lower than 6. It means we are talking about this thing. So it should be p x less than 5.5. Okay. Next one is, any question, guys? Yes, Abdullah, any question?
We have to deal with negative numbers.
No negative numbers, because trials cannot be negative. Thank you for asking good question. Okay. Probability. Here I have taken another example. If px is less than or equal to 7, less than or equal to 7, it means this is our bar, this is 7, okay, and this should be 6.5 and this should be 7.5. Yeah, it is showing less than and equal to 7. So our 7 is finishing here at 7.5. Can you see? less than and equal to 7. So our 7 is finishing here. This is the last value of 7. So less than value, it means we are taking all these values this side. So this we can write down probability x less than 7.5. Here you no need to put equal sign because that hardly affects your answer. So in binomial distribution, equal, less than and equal to change into less than, greater and equal to change into greater than. So x less than 7.5. Now another example, if x is between 8 and 9, and here at 9 it is equal sign. Remember, at 9 is included but 8 is not included. So after doing continuity correction, can you do it for me? What should be your value? 8 and 9. 8 and 9. Yeah, please try. This is our 8 bar and this is our 9 bar. So what should be your answer here? This is 7.5, 8.5 and 9.5. So anybody else, please, what I should write here? Definitely x will be in between. You need to fill up the gap. What is coming here and what is coming here? Anybody else? Yeah. 7.5 first value and second one is 9.5. So 9.5 is okay, but it should not be 7.5 because it is showing 8 and greater than. If you see here, x is greater than 8. So greater than 8, our last value of 8 is this one. So greater than 8 means greater than 8.5. So it should be 8.5. Is that fine? And the last one is probability when it is between 10 and 11 and they both are included. 10 is included and 11 is also included, right? So if we draw here continuity correction, and this is our 10 bar and this is our 11 bar, this is 10.5 and this is 11.5. So which value we are taking here? Okay, so definitely x will be in the middle. So we need value here and we need value here. So in this yellow area, what is coming here and here? Please find out. Yes, this time I'm asking girls. Any girl can explain what is coming here? 10 is included and 11 is also included. Yeah, please. 10.5. First value or second value? First value can't be 10.5 because 10 is starting from, sorry, I have written wrong. It should be 9.5. So it should be which value? 10 is starting from here, 9.5. Can you see, Mariam? 10 is starting from 9.5. Yeah. So which value is coming here? 9.5. Okay. And what is the last value here? What is the last value here? 11.5. Thank you. So it should be between 9.5 and 11.5. Is that okay? Yeah. So this is what you need to do in continuity correction. So in next lesson, we are going to do, you have question, Mariam? Yeah, no, x is greater than or equal to 10. It is not, 10 is less than x, but x is greater than or equal to 10. So you see other way around. X is greater than 10, so you are moving right side of 9.5 because this is our 10 value, which is starting from 9.5. Okay. So in the next lesson, we are going to do more exam questions based on continuity correction. Till then, goodbye. Thank you.